have ganache, right? Yeah.
Who here is having issue with SolC CLI? Just for like using SolC bin or SolC AST. Who here is having installation issues for SolC?
No?
No issues? Everybody's on Windows and everything? Yeah, for some of us, I guess SolC is not, it's showing the check bindings is not, yep.
Right, right. Okay, I haven't tried it on Windows yet, so maybe I
No, but
should.
even on Mac.
Even on the Mac,
Yeah,
right.
I think it's a versioning issue for like, for stuff. Yeah.
Okay, yeah, I'll talk to you after this. Maybe you'll figure something out. All right, cool. So, start again. So, next up we have Ganache. What is Ganache? It's a simulated blockchain that you can run locally. But before we get into that, what I'd like to do is actually talk about all the tools that we'll be covering today and how they fit together. Right. Make that bigger. All right, should be big enough. Doesn't get bigger. So these icons here with a folded corner, that's those are your Solidity smart contract. That's your Solidity smart contract, and all the other things like they sort of like they're basically files or I guess file-like things. So we've got the smart contract itself written in Solidity. We've also got the ABI. And we've also got the EVM bytecode, compiled EVM bytecode, right? And then we've also got the deployed EVM bytecode. But in between getting from Solidity to the these three other stages, we've also got one more thing, which is we also need the tools and to understand how these files flow between the tools, right? So the tools that we'll be talking about, or programs, if you want to think about it that way, are the rounded corners. So we have the Solidity compiler. We also have Ganache, which we're talking about next, and then we also have Truffle. Those are the three things that we're talking about today. And previously, you would know what a web browser is. What Web3.js is, we'll talk about it not next session, but 2 sessions from now, session 6, and MetaMask, which we just covered in the last section. So for now, think of Web3.js as a client library that that basically makes it easy for you to interact with smart contracts. That's essentially what it is. Otherwise, you would have to, I guess, be able to construct smart contract call data yourself, and then do some cryptography and sign it yourself, that sort of thing. So you don't want to do that. Web3.js takes care of it for you. But we'll get into more detail in session 6. So this is sort of how the flow works. So you get your smart contract. You put it into SolC and you get these two things, and that's what we did before. Like that corner section. That's what we just did. But what we're going to do next is we're going to put this compiled EVM bytecode, submit that to Ganache, which is a simulated Ethereum node, and also therefore simulating an entire the entire Ethereum network, but it's actually just a single program running in a computer. And then you get the deployed EVM bytecode, right? And in order to do this as a runner, we'll be using something called Truffle, right? So Truffle, you don't actually call SolC yourself directly, which is what you just did. We'll be using Truffle to call SolC, right? And then SolC will kick this off, right? And then you'll take the compiled bytecode, and Truffle will send that to Ganache, and then obtain the deployed bytecode, and that Truffle will save that again. Then what happens is you, as the developer, manually says, okay, I'm going to take the compiled address, which is where this deployed bytecode exists in the blockchain, right? The address of that, I'm going to take it, and I'm just going to tell Web3 about it. And then I'm also going to take the ABI JSON file that was output by SolC and is available via Truffle. Truffle will actually save a copy for you, and I will tell Web3 about that as well. So Web3 has the ABI JSON as well as a compiled contract address, and once it does that, it knows how to interact with the smart contract. And how that actually works is your DApp, your web application, is running in Chrome says, hey, I want to do function, honk car, for example. So it tells Web3, I want to call honk car, and these are two parameters, and you call it with a JavaScript function, right? And it'll literally be cars, the contract name, dot honk car, and then your parameter 1, which is the car ID, and parameter. So like if you know JavaScript, like it's just you just need to do that. Like it's very straightforward. But what Web3 does is it looks at the ABI and it looks at the parameters that you passed into in the JavaScript function, and it constructs call data. Then it sends that call data to MetaMask. MetaMask asks for your permission, as we saw in the previous session, and it signs that transaction, and then that is submitted to the Ethereum node, which in this case is Ganache, but it could, like this flow that I'm describing, you can substitute Ganache with a real Ethereum node or Infura or something like that. So this is the Ethereum node, and then that will execute the deployed smart contract as it exists on the blockchain, which is EVM bytecode, by parsing out the call data, verifying that it's been signed correctly, and passing in all the values, and then whatever result that occurs, that gets returned from Ganache to MetaMask. Actually, maybe not to MetaMask, maybe directly to Web3. I gotta go check that. So anyway, and then it just bubbles back all the way up the chain, and then eventually it flows back to Chrome. So that is the flow. That's how the tools fit together, and that's how the files fit together. And hopefully that's puts things into perspective. But I recognize that we're kind of jumping ahead. I just wanted to give a sort of overview before we delve into things. So yeah, we've got so that's an overview of the tools. So what is Ganache, right? It simulates an Ethereum network, right? Including both the blockchain and the EVM. It also creates several test accounts, which we'll see shortly, and it runs on localhost, meaning like you can just run it as a server on your own computer. You don't have to deal with Geth, right? So Geth or Go Ethereum is the I guess the standard Ethereum node, and what it does is if you spin up a new node, it takes a huge amount of resources, both computationally and in terms of like disk space required, as well as your own time, right? I think it's like tens of hours right now to download the blockchain in full, and Geth needs that. So if you're interacting with the real Ethereum mainnet, you do want Geth, right? That's necessary, as I've explained in the previous sessions. But if you're just developing, you just say, I don't care about the rest of the blockchain, and I don't care whether it's a real blockchain even. I just want to simulate it. And getting set up on Ganache literally takes like a minute, and you compare that with interacting with the real blockchain via Geth. You want like some sort of snappiness to it when you're actually developing on it, because you have to take many iterations and that sort of thing. Like everyone here who has written in code before will know that you never get code running correctly the first time bug free, right? You don't want to have to spend hours on that each time. You want to set it up. You just want something snappy. So that's what Ganache is for. You can, if you've already got a Geth node set up and it's all working, then great. Use it. You can substitute that Geth node for Ganache. Basically, both of them, they talk the same thing. So there's a spec called JSON RPC, which is a communications protocol that Ethereum nodes are supposed to expose at a port number. So yeah, that's so Ganache just basically has the same thing. It's just that behind the scenes, it just simulates the blockchain rather than runs a real one. So setup. Ganache installation instructions is over here. This is from the official site. This is a GUI, right? It's a graphical user interface. So what will happen is you download either an AppX file, a DMG file, or an app image from their website, and after you've run that, you'll spin it up, and then you just want to click on new workspace or quick start, whichever you feel like, and you wind up with a screen that looks like this, right? And as mentioned before, it has 10 pre-generated accounts or maybe more, where it gives you a bunch of addresses. It gives all of them 100 ether. They're not worth anything because they only exist in your localhost, not any blockchain. So it's like even less worthless than than testnet ether, because it only exists on your computer and never will exist anywhere. Yeah, and the things to take note of are the network ID, the RPC server, and the mnemonic. So if you want to access these same addresses within MetaMask or any other BIP39 compliant Ethereum wallet, you can just copy and paste this mnemonic into that, and it'll give you the same set of addresses. And we went into a lot of detail in the previous session as to how exactly that works. But for this session, just know that it just works magically, because the same seed phrase was used. Yeah, and then the network ID and the RPC server. So this is the local host and a port number where the Ethereum node, the simulated Ethereum node that Ganache represents, is running or exposed on. And the network ID is just an attribute that you'll need in your configuration. So those are the things to take note of in the screen. So what we're going to do now is a hands-on, right? Basically, all I want you to do is this. Just fire up Ganache if you've got it installed already. And that's how long it took up to spin up a blockchain, right? Literally seconds. Compare that to Geth. Yeah, so we've got exactly what I just said. I don't think I can zoom into this one, so yeah, you'll have to be happy with that size. Yeah, it's just one. What you'll need to do later on is to copy this as well as the network ID. I think most of the time it's going to be the same. So I think, where was I? Yeah, cool. So that brings us to the end of Ganache. That was really, really simple. Did anyone have any problems installing Ganache earlier on? Who was not able to get to the screen where you have the 10 addresses and the mnemonic and all that? Oh, everyone. Excellent. Okay, cool.